Today, I want to introduce you to a new caching technology called CacheDit. Its main function is, of course, to enhance the inference speed of DIT models, compared to traditional TeaCache or other types of caching technologies. This one has quite a few advantages. First of all, its core logic is different. TeaCache simply reuses the result generated in the previous step. CacheDit, on the other hand, has a prediction function. It uses a Taylor series to calculate the result of the next step. You can simply think of it like this based on the current speed and current acceleration. It calculates exactly what the speed will be in the next second. Because CacheDit has this prediction capability, it can correct errors in advance. Currently, we can already use this technology in ComfyUI. It can bring a speed boost of 1.4 to 1.6 times for our DC models. Typical representative models include Zimage, Zimage Turbo, QEE, LTX Video, and the WAN 2.2 model. Additionally, for different models, the corresponding sampling steps will differ, and the acceleration effect will vary as well. There are two very important parameters here. One is called warm-up, and the other is called skip interval. What do these two parameters mean? You can simply understand it this way. During warm-up, which is the preheating phase, it must perform a full calculation. It cannot perform caching or prediction. The skip interval refers to the steps where caching and prediction happen. For example, if this value is set to 5, it means that within these 5 steps, the first step is fully calculated and updates the cache, while the following 4 steps are skipped directly. Installing this extension is also very simple. First, we need to clone it into our custom nodes folder. After that, install the corresponding dependency packages. It offers a simple usage method mentioning 3 types of models. The first is called CacheDit Accelerator, which is specialized for image generation models. You just need to place it after the base model. The second one is specialized for the LTX video model. The third one is specialized for the WAN model. So, how effective is this extension, and what are the potential pitfalls? Next, let's actually test it out for you. As always, I have built the workflow on Running Hub. You can access this platform via Running Hub in the ComfyUI field. Running Hub is a fantastic online workbench because whenever new models or extensions appear, they follow up immediately. You can register for Running Hub using the invitation link in my video description to get 1,000 free credits. Additionally, logging in daily gives you 100 bonus credits, so you can try out your own workflows. First, let's look at Zimage Turbo. I have already added this node. You can right-click, select Add Node, and you will find CacheDit. The 3 common nodes we mentioned are all in there. I am currently using the first one. Please note the corresponding parameters I set, 3 and 2. You can't just write these randomly. These are what we saw on the official website earlier. This means it performs a 3-step warm-up, and then caches once every other step. Now, let's turn it off first and run this workflow to check the execution time. Okay, the sampling is complete. Let's look at the duration. It took about 10 plus seconds. Now, let's enable the caching technology and run it again. Notice that the time has clearly improved. So, this acceleration technology is indeed very effective. Regarding the parameters inside, as we mentioned, this toggle enables or disables it. Here you can select the model, or you can leave it on auto, though we recommend selecting the specific model. We've already explained the warm-up and interval parameters. Then there is the option to print summary info. If you enable this, you can see the corresponding information in the console or your backend. Let's take a look. There is a summary here. It shows the total steps run for all generated images, how many steps were calculated, and how many were cached. For instance, just now, I calculated a total of 6 steps. Why 6 steps? You should be able to roughly calculate this. I had a total of 9 steps. The first 3 were fully calculated warm-up. The remaining 6 steps were set to calculate 1 step every 2 steps. So, adding them up, it totals 6 calculated steps. This explains the 2 parameters we introduced earlier. The overall acceleration effect is about 1.5 times. We can execute it again. Let's check the duration. It is 8.36 seconds. It seems to have gotten a little faster. This time it was 18 steps total. We calculated 11 steps, cached 7 steps with a hit rate of 38.9%. The acceleration effect is also estimated here. Many people might be confused as we generate more images. Will the speed get faster and faster? Let's run it again to check. It went down to 6.89 seconds. Then let's run it one more time. Look at that, it went back up. So what does the sampling time depend on? It depends on the similarity between the previous image and the next image you generate. For example, the beautiful women generated earlier were all facing right, but this one suddenly faced left. Because of that, the overall speed dropped again, and the time went back to 8.40 seconds. Therefore, don't subjectively assume that the more images you generate, the faster the acceleration will be. All calculations happen within the current sampling process. It simply adds a Taylor series prediction. Similar situations apply to QEE image as well, so I won't demonstrate that separately. Next, let's look at a special case. This is a workflow we used previously. This workflow actually uses two stages of sampling to balance generation quality and running speed for image. We built this workflow. I have a very detailed explanation of this in a previous video, which you can check out. The main feature here is that it uses two models for a two-stage sampling, somewhat like the high-low noise sampling in WAN 2.2. The first stage is performed by Image Turbo, and the second stage is performed by Image Base. I added the cache acceleration node here as well. I'll turn it off first, and let's generate it once to check the timing. It took about 38 seconds. Please note when testing, try not to use the first run as the standard, because the first run includes model loading time. We should use the second run once the model is cached. To look at the sampling time, it is 38 seconds. Now, let's enable the node and run it again. Look at that. We used 40.5 seconds. Actually, the acceleration effect isn't very obvious. We can run it again. This time it is quite obvious, 33.4 seconds. Some might ask, why is the acceleration effect insignificant in this workflow? It is because you use two main models. The second model cannot retrieve cache data from the first model. Another reason is the parameter settings. The model I am using now is image base. According to official settings, it should be 50 steps, with the first 10 fully calculated, and then fully calculating only once every 5 steps, skipping 4. But right now, you can't use that as a reference. The reason is that I only have 20 steps in total. The first 5 steps are sampled by Turbo, and the remaining 15 steps are sampled by Base. In this case, you can make some slight modifications. For example, set the warm-up steps to 0. You can draw an analogy, assume the first stage has already done the full calculation work for you. But regardless, once you adopt a structure with two models, you will find that the acceleration effect is not that significant. There's another workflow you need to be aware of. What you see now is an LTX video workflow. I added the node here as well. I'll turn it off and sample it first to check the total time. It took about 57 seconds. Now, if we enable this node, we encounter two problems. First, although this is an LTX video workflow, I am using a distilled model. Therefore, my total steps aren't 20. I only have 8 steps. This means I can't set the steps using the standard method. I'll just set it arbitrarily here. Let the first 3 steps fully calculate, and then calculate once and cache once every 2 steps. Let's turn it on and execute. We'll focus on the effect and timing, okay? Sampling is done. Look, the dynamic motion is fine, and the generation quality isn't much different from before. The time taken was about 54 seconds. Actually, the acceleration isn't very noticeable. We can run it again, about 56 seconds. Basically the same. Finally, let's talk about WAN 2.2. I won't add the node. I'll just give you the conclusion. Because for WAN 2.2 workflows, we generally use an acceleration LoRA. The high-low noise sampling usually only has 4 steps. In this case, it is impossible to use this cache acceleration technology because your total step count is simply insufficient. So you'll find that while this acceleration technology sounds very practical, its application scenarios might be limited, now that we have acceleration LoRAs and distilled models. Currently, for most of you, CacheDit technology is likely more useful in image generation scenarios like Image or QEE image. For video generation workflows like LTX video and WAN 2.2, we typically won't be able to use it under standard conditions. That is all for today. What are you waiting for? Go ahead and give it a try yourself. Follow me to become someone who understands AI.